Question 3 in Exam 2 has multiple choice or short answer questions. We'll start with Part A. In the figure, m sub A is equal to 2 kilograms and m sub B is equal to 8 kilograms. If a force F sub H is equal to 30 newtons, what is the magnitude of A in SI units? Well, as shown in the figure, this is a frictionless surface. So once F sub H exerts a force on A is then going to exert a force on B, so that both bodies will move together due to their equal and opposite forces on each other with a constant acceleration and the same acceleration. So there is an acceleration constraint between the two. And we could say that F sub H having a problem with my pen. F sub H is being exerted on a composite body composed of mass A plus mass B. And it's causing this total mass equal to mass of A plus mass B to have an acceleration equal to A. So if we want to solve for A, we simply divide F sub H by the total mass. So that's 30 newtons over the sum of the two masses. So that's 10 kilograms. So A is equal to 3.0 meters per second squared. In Part B, an object of mass m is hanging by a string from the ceiling of an elevator. The elevator is moving upward, but slowing down. What is the tension in the string? So here is the body. It has a tension force acting up, and the weight is acting down. They tell us it is moving upward, so the velocity is upward, but it's slowing down, so the acceleration must be downward, which means that the downward force, mg, must be greater than the tension force acting up. So the tension in the string is less than mg. In Part C, when a car goes around a circular curve on a level road, assuming the car does not slip, which of the following is true? Well, we know when a car goes around a curve, let's say the car is going into the page at a distance r from the center of curvature. Then there is a static friction force that keeps it from slipping. And this is the agent of centripetal force, which causes it to have a centripetal acceleration v squared over r. If the velocity if the velocity increases, then the frictional force must increase also for the car to go around and to continue to go around the curve without slipping. So the correct answer is 2. The frictional force on the road increases when the car's speed increases. In part D, determine the following for the figure on the right. Assume the box starts at the top of the inclined plane and is accelerating down the rough plane. The kinetic coefficient of friction between the box and the surface is mu sub k. In the first part of part D, clearly identify all the forces acting on the box. You can do this by drawing on the diagram of the box. So the forces are once again, I'm having a problem with my Apple Pencil. It's not charged very much. Okay, so now the gravitational pull of the Earth is acting on the mass, causing a downward force mg, and there is a frictional force F sub k acting up the incline. In the second part, we are asked to draw the free body diagram of the box on the axis provided to the right, actually below. And we break up any vectors into components so that all the forces are either on the axis of motion or perpendicular to it. Well, if we call the direction of motion the x direction, then on this figure down below, we would have F sub k acting in the plus x direction, and the x component of the weight acting in the minus x direction. And then we would have the normal force acting in the plus y direction and the y component of the weight acting opposite to the normal force. And then in the third part, we're asked to describe how each force identified in part 1 will influence the acceleration. I see in part 1 that I left off the normal force, excuse me. So if we consider the motion or the forces that are acting in the direction of the motion, we have the sum of the forces in the x direction is equal to F sub k, which is acting up the incline, intending to retard the acceleration, and mg sine theta is acting down the incline and is tending to speed it up. So both F sub k and the x component of the weight are influencing the acceleration of the object, obviously, from this equation. Now let's consider the forces acting in the y direction. We have the normal force acting in the plus y direction, and we have the y component of the weight acting in the minus y direction. And they sum to zero because there's no acceleration perpendicular to the plane. And that tells us that the normal force is equal to mg cosine theta. And many of you would say, well, the normal force is not really doing anything here, not influencing the acceleration. But if you were to write down that what the definition of f of k, which is equal to mu sub k times the normal force, then the value of the normal force influences the value of f sub k. So indirectly, one could say that the normal force equal to mg cosine theta affects the friction force, in that the greater the component of the weight acting down, the greater the friction force, and the greater the retardation. And that concludes this question.